So today we're going to solve for theta, okay, and using special angles. So that's our goal. We're going to go backwards and solve for theta. Now, to first start off with the skill, we're going to be reviewing how to solve for trig ratios. So we're going to go forward, and then we're going to go back. Go forward, and then go back. So let's talk about the triangles that we're going to use. We have like three main triangles, and we have what we call a 30, 60, 90 triangle. And we said this was 1, 2, square root of 3. Those are the relationships for this type of special triangle. Mr. Ko, what if the triangle is bigger? Sure, if the triangle is bigger, this could be 2, 4, 2 square root of 3. And this is also a 30, 60, 90 triangle. We can draw this triangle in a lot of different ways. We can flip it over with the right angle's butt sticking up. See, it's almost like that, right? The butt sticking up. So that's a 30, 60. So here's what you always want to write. You always want to write the right angle, okay, is here. And the 1 and the 60, 1, 60, and 90 are always in the same corner. Hypotenuse is 2, and square root of 3 is that long, skinny side. I think of it that way. We could also draw it facing away. If I write 30, 60, 90, the 1 is always next to the 60, the square root of 3 is always next to the 30, and 2 is always the hypotenuse. So I think this is one of the easiest ways to remember it. Either you could say 60 and 1 are together, or you can think of it as square root and 3 are always together. Square root and 3 are always together. Okay? So let's go ahead and review some of this. If I ask you for the sine of 60 degrees, sine of 60 degrees, I want you guys to do these steps. So everyone's going to do these steps right now. First, draw an easy cross, an X and Y axis. Just draw an easy cross. No joke. Just draw this easy cross. Next, draw 60 degrees. 60 degrees is in quadrant 1, 2, 3, or 4. Quadrant 1. Doesn't have to be perfect, but you have to draw an angle in 1. Mr. Ko, that looks more like 45. I don't give a crap. This is a rough drawing, and you have to be able to draw these quickly. Don't waste too much time. Oh, Mr. Ko, can you please draw it more like, a little higher, please? Sure, but I don't want you guys to waste time with that. I want you guys to be able to draw a visible, something that you guys can see. A visual representation. So write 60 in the corner. Done, 60 in the corner. Everyone go with 60 in the corner? Okay, now if I know this is 60 and this is a right triangle, you have to fill out the rest of the sides. I want to see, can you guys fill out the rest of the 3 sides right now without my help? I'll give you guys 5 seconds. Hopefully you looked at our previous examples, and 1 is always next to 60, square root of 3, and 2. Now, if you can draw these triangles in like 5 seconds, you don't need a calculator. You don't need to memorize a sheet of identities. Just draw the triangle. Because 60 degrees is shown, and we want to find the sine. And the sine is opposite over hypotenuse. Please look at the angle 60, which is in this corner here, and write down the opposite and the hypotenuse and the adjacent. Let's label the sides. The opposite, adjacent, and hypotenuse. Do you need to label them? Once you get good at this, no, you don't need to label it anymore. But I think as we start, we want to make sure we can label them so we know which side is which. So the opposite is square root of 3, and hypotenuse is 2. And in the IXL practice, a lot of you guys did really well if the triangle was drawn for you. You just have to copy the sides. If the triangle wasn't drawn for you, we had to do extra work. But our goal is to draw the triangle first, and we will always know what the sides are, the ratio. Okay, we're going to do another problem. What is the cosine of, let's do 150 degrees? So if you memorize what the cosine is at 150 degrees, it's going to be negative 1 over 2. Wait, no, sorry. It's going to be negative square root of 3 over 2. Okay, memorize that. I memorize it. But honestly, I'm actually imagining it in my head. So we're going to practice that. Let's draw a cross. Draw a cross. Where is 150 degrees in quadrants 1, 2, 3, or 4? So we're a little bit short in quadrant 2. Is everyone okay that this is actually a special triangle? That's a 30-degree angle. Let's draw the triangle. Always draw the triangle so the right angle is sitting on the floor. Hey, this is a 30, 60, 90 triangle. Right now, please, next step, label those 3 sides. So I'm going to write down the steps now. 1, cross. 2, angle. Once you draw the angle, draw the triangle. 3, label the triangle. Label sides. Let me write that instead. Label sides. And then double check. Are any of these negatives? Okay. 1, we drew a cross. We drew the angle. We completed the triangle. Follow that up now with labeling the sides. Are any of these sides negative? So let's forget that. It's going to be 1, 2, square root of 3. Remember, the square root of 3 always goes with the 30. As a hint, going left and up. Going left and up. Which of these will be considered negative in Algebra 1? The square root of 3. Now you did it. You have all 3 sides of a triangle. Now the question is, what is the adjacent and hypotenuse for that triangle? So looking at that triangle now, since we drew it out, go ahead and tell me what the adjacent and hypotenuse is. So I'm going to throw up a poll. So go ahead and click which ratio did you get, as well as if it's positive or negative. If it's negative, click negative also. Negative is on the bottom. Remember, we're dealing with adjacent and hypotenuse. Looking at the triangle, would that be positive or negative? Okay, I got 4 answers out of 41. Come on, wake up, people. If you have no clue what's going on, please click undefined. If you have no clue what's going on, click undefined. Okay, that's about half you guys. That's good. All right, end poll. Let's go share the results. I have a lot of you guys are on board. You wrote negative and you wrote square root of 3 over 2. And some of you guys are still a little confused. So let's go ahead and look this over. First things first. Since I have a triangle drawn already, let's go ahead and label the sides. From the 30-degree angle, my reference angle, that's what we call the reference angle, that's going to be opposite, hypotenuse, and adjacent. Cosine is always the fraction adjacent over hypotenuse. Now looking at the triangle, since it's already drawn, the adjacent is square root of 3, negative, hypotenuse is 2. Okay. Now really quick, in the participants, can you guys click yes if you see that ratio, that's negative square root of 3 over 2, and no if you're still confused how I got those numbers. Okay, thank you very much. It looks like about half of you guys are kind of not bad. Okay, thank you. So we're going to do this again. So we could do this on a calculator. Now, let me go and show you a calculator here. If I wrote angles 150 Oh, duh, it's going to give me a commercial. Go away. So I'll make sure I'm in degrees. Angle 150. And I'm going to hit cosine. Cosine here. Negative square root, no, negative 0.86. And that is square root of 3 over 2. That is square root of 3 over 2. Square root of 3 over 2. Got it. We're going to do another one. Well, let's do one in quadrant 3. So we're going to do the sine of, let's do 240 degrees. So we're going to follow the steps. So steps are, first step, draw the cross so we can visualize this. Let's draw the cross quickly so we can visualize it. Everyone just draw a cross. Step 2, draw an angle that's 240 degrees. Where would 240 be? 240 is going to be, this is 180, this is 270. So we're kind of like here. Okay, after we've drawn the angle, draw the triangle. Now, what do you think this angle here would be? To get from 180 to 240. Remember, it's only going to be one of our 30, 60, 90, or 45 possibilities. Those are the only options that we have. Well, it's not 30, so let's try 60. Yeah, that's 60. Oh, great. If we know it's 60, let's label the sides. We've seen a 30, 60, 90 triangle already. It's going to be 1, 2, square root of 3. Follow this up. Would any of these be negative? Going left and down. Turns out they're both negative. Now that we have all 3 sides of the triangle, we just need to copy the right sides. Sine is opposite over adjacent. Now, if you forget, remember we have SOHCAHTOA. SOHCAHTOA. Which sine is opposite hypotenuse, cosine is adjacent hypotenuse, and TOA is opposite and adjacent. Okay, opposite and adjacent. Okay, I want you guys to write down the ratio, write down the answer. I'm going to have you guys fill out a poll. Remember, if it's negative or positive, you want to include that. Okay, let's take 20 seconds to fill this poll out.
Mr. Ko?
Yep.
Are you also going to be going over it?
So looking at the 90-degree triangle, we are faking it till we make it. So I pulled out this fake triangle with adjacent of 0. Remember, at 90 degrees, there is no x value. There is no x value. It's 0. So we call it 0, 1, 1. The opposite is 1. Hypotenuse is 1. 1 over 1, which is 1, which is what we said we should be expecting. For this same triangle, let's look at cosine. Since a triangle is already drawn, what is the cosine of this triangle? Adjacent over hypotenuse, which is 0, which is what we wanted. I'm going to do another one now for you guys, okay? The other one is this. Let's do 270. That's usually a tricky one. 270, and we'll do sine again. Step 1, draw the cross. Step 2, draw the angle. Followed by, how would I draw the triangle? We never draw triangles this way. No. We never draw triangles like hanging this way either. The triangle is always facing away from the y-axis. So let me put a dot here. This is 270 degrees. Excuse me. So which of these values would be a 0? The x or the y? Remember, this angle goes straight down. So is there really an x value? No, that's our 0, 1, 1. We just filled out the 3 sides of a triangle. Are any of these going to be negative? Well, hypotenuse is negative, never negative. But didn't we go kind of 0 and down? The 1 is negative. So the sine would be opposite over hypotenuse. In this case, a triangle, the opposite would be -1. Hypotenuse will be 1. Answer is -1, just like what we said it should be. Yeah, we need to know this for our homework, but this is also a review because we did cover it last time. But I don't mind covering it again. It's fine. So these were our special 90-degree angles. So we talked about drawing a 0 and 1 triangle before. Let me just do one more. Let's do the tangent of 180 degrees. So first step, just draw a cross, draw 180. Oh my gosh, 180 isn't a triangle, but remember we fake it. So I'm gonna pull this out of the grave. We said we're just gonna pull this up. But when I pull it up, is there really a height? If you're lying on the floor, you're dead. You have a 0 height. 0, 1, 1 triangle automatically. Are any of these gonna be negative? Adjacent is negative because we went left. Hypotenuse is always positive. Now, since we're looking at tangent, that's going to be opposite over adjacent. The opposite angle, so opposite side of my reference here is going to be 0. Our adjacent is -1, right, 0. To prove to you that this is true, I'm going to say if my angle is 0, okay, if that's 0, what's the tangent of 0? Answer 0. Ooh. Okay. Okay. All right. So now that we've learned how to go forward, meaning if I give you the angle, you tell me the sides. If I give you the angle, you can tell me the sides. If I give you the angle, you can give me the sides. We're going to go backwards now, and I'm going to give you the sides, and you give me the angle. Okay, I'm going to give you the sides, you give me the angle. And it might seem a little confusing when we first start, but hang on. So again, we're back to our original question, solving for theta. And we're going to almost do all these same processes, okay? Almost all these same processes. So if I told you sine of theta is equal to 1/2, I told you theta, so I'm looking for theta, but I'm given the sides 1/2. Now we got to do some detective work here. First, we're going to draw a cross. And we know theta is someplace in one of the 4 quadrants. Which quadrant will it be in? Now, here is something I want to remind you, that we know that sine, cosine, tangent are sometimes positive and sometimes negative, depending on which quadrant we're in. So we're going to go back and use a special trick, and we're going to say, all students take calculus. Now, how is this helpful? It tells me every sine, cosine, and tangent is positive in quadrant 1. It is always positive in quadrant 1. And let me finish this part. And sine is positive in quadrant 2. Tangent is positive in quadrant 3, and cosine is positive in quadrant 4. Now, is my question here, sine of 1/2, is this positive or negative? That's positive. So we're going to be in quadrant 1 and also in quadrant 2. We have 2 possibilities now. Now, we're going to do some detective work. Okay, first, we realize sine is cosine, so we can have 2 possibilities. I'm free on Friday. I have 2 numbers I can call. Which number am I going to call? Okay, I'm married. I don't mean that. I'm just using an example, okay? So we also know some characteristics of sine. Sine refers to opposite over hypotenuse, doesn't it? So in this case, 1 is the opposite value and 2 is the hypotenuse. Looking at this corner angle here, that's my reference angle. The opposite is 1 and the opposite is 1. These are both 1 because they're opposite from my reference angle. And the hypotenuse is 2. Oh my goodness, we have 2 sides of this triangle. what's the third side going to be? Have we seen this triangle before? 1, 2, 1, hypotenuse 2. Third side has to be square root of 3. Careful, the one on the left is negative. So if we're looking between angles 0 to 360, and then we write this as a range, or in this case domain, from 0 to 360, that's my first circle. How many possibilities do we have? We have actually 2 possibilities. Now, we're going to move on. What type of angle is my first triangle? What type of angle sits in this corner? We said square root of 3 is always 30. Square root of 3 is always 30. So theta is going to be 30 degrees. If I write sine of theta, so sine of 30 degrees, isn't that this triangle here? That's 30 degrees. And the sine would be opposite 1, hypotenuse 2. Well, also, look at my second triangle here. What angle would take me there? Now be careful. What I mean is counting from 0 degrees over here. If I wanted to go all the way up to this angle, this line here, right? That's my angle. What is that full measure? What's that full measure? Well, if the leftover bits are 30, this has to be 150. So my next angle is 150 degrees. Now let me write that. If I write sine of 150 degrees, hey, isn't that this triangle on the left? That's 150 degrees. What's the opposite of that triangle? Look at the triangle. What's the opposite? Opposite is 1. Hypotenuse is 2. So this is actually kind of tricky. And one of the reasons why it's tricky is because there's more than one answer. And we have to be really creative on how we can visualize those 2 possible answers. So let's try this again with a different sine, cosine, tangent. Here we go. I'm going to give you guys the cosine of theta is, let's do 1 over 2. So the question is, what angle will give us triangles with adjacent 1 and hypotenuse 2? And you might say, how the hell am I supposed to do that? That seems like it's impossible. Well, we are going to draw our cross first. Everyone draw that nice cross, not like me. Oh. Gosh. Draw that cross. All students take calculus. So please notice that cosine is positive. That's positive. So in what quadrant is cosine positive? Well, Mr. Ko, if I draw it over here, isn't my cosine negative? Isn't my cosine negative down here also? Because my adjacent over a hypotenuse would give me a negative value. So we know angles in quadrant 2 and 3 don't work. So quadrants 1 and 2. And I think all students take calculus, makes it easier for us to visualize. So I'm going to draw a triangle on top and one on the bottom. That's slightly off. Okay, we're going to look at the triangles in 1 and 2. No, sorry, quadrants 1 and 4. So because this was positive, that gave us a hint. The triangles must exist in quadrants 1 and 4. Next clue is my adjacent is 1 and my hypotenuse is 2. So if my adjacent is 1, that's my reference, that's my reference. Adjacent is 1, and my hypotenuse is 2. My adjacent is 1, and my hypotenuse is 2. So we're filling out 2 triangles at the same time. Because the triangle could have happened in quadrant 1, or it could have happened in quadrant 4. Have we seen this triangle? 1 with hypotenuse 2. That means my third side is going to be what? Square root of 3. This is a triangle that we've seen before. Just be careful. Are any of these negative? In quadrant 1, is the square root of 3 or 1 negative? In quadrant 4, is the square root of 3 or 1 negative? The square root of 3 is negative. So Now that we have the triangles written and we know all three sides, we can find out what that angle should be. What angle goes next to 60? But dang it, what angle goes next to 160? Somewhere at 60 degrees in this corner and in this corner. Those are actually 30, 60, 90 triangles. Okay, first triangle in quadrant 1, theta is going to be 60 degrees. If I want to get to my second angle, I have to start from 0 and walk all the way past 180, past 270 to what? What would this have been if it was 60 degrees short of 360? That's going to be 300. So our goal is to work backwards, solving for the possible answers that we have. And in this case, we have in a full circle from 0 to 360, we have, it could be 60 degrees or 300 degrees. Now, just to prove that to you, if I write cosine of 60 degrees, first step, draw a cross. In 60 degrees, draw the angle, draw the triangle, write 60 in the corner. What side goes next to 60? 1 or square root of 3? 1 or square root of 3? Square root of 3. 2 and 1. And the cosine, whoops, not square root of 3. Remember the 3's go together. That's a 1, 2 square root of 3. Hopefully you guys are screaming, no! So the cosine would be adjacent over hypotenuse. Yep, that's the 1/2 we wanted. And just to prove this to you, we're going to plug those into the calculator to double check. 60 cosine, 60 cosine is 0.5. It's the 1/2 we wanted. How about at 300? 300 cosine is also the 0.5 we wanted. So we found the two answers that worked. Now, do we always talk about the full circle? Answer is no. What if theta was between only 0 and 180? So to visualize this, what if theta, what if I said cosine of theta is 1/2, like we said before? Cosine of theta is 1/2, but I only want theta between 0 and 180, only up here. Would quadrant 4 have been a possibility? No, we couldn't have used it. So sometimes IXL, sometimes your book will ask you, hey, don't give me the whole circle. Which of these possibilities would only be in quadrants 1 and 2? So the answer here, theta, would be 60. Only in quadrant 1. We don't have to draw the triangle in quadrant 4. Let's do one last example. If I give you, let's say, the cosine of theta is negative square root of 3 over 2. Negative square root of 3 over 2. I'm thinking in my brain, cosine is adjacent and hypotenuse. That's what they refer to. So when will the adjacent, when is cosine negative? There's a couple ways of looking at this. So maybe I don't know. Maybe I'm not sure what's going on. I'm going to first draw a cross. Everyone has to draw a cross. Everyone, please draw a cross. Next thing, write all students take calculus. A, S, T, C. All students take calculus. Quadrants 1, 2, 3, 4. Cosine is negative here. See how it's negative? In what quadrants would cosine be negative? In 1, 2, 3, or 4. Remember, cosine is positive because in quadrant 1, because everyone's positive. Cosine is positive in quadrant 4. So it must be negative in quadrants 2 and 3. Sine is positive, but cosine and tangent are both losers. Tangent is positive, but cosine and sine are both losers. Cosine is positive, but sine and tangent are both losers. Everyone else is a loser. So when is cosine negative? You see that it only happens in quadrants 2 and 3. I draw the triangle. Now, fill in the sides that we do know. We said adjacent is square root of 3. Yeah, you're square root of 3. And guess what? You're also negative. See, you're also negative. What's the hypotenuse? It's going to be 2. And it turns out square root of 3 works for both triangles. That's why I drew in the middle. This is the hypotenuse is 2. The third side is a 1 and a 1. 1, 2 square root of 3. Last step, what angle would be in those corners? Square root of 3 is a 30-degree angle. This is a 30-degree angle. Counting from square 1. 0, what's my first angle? What's my second angle? So, first angle, we're short of 30 degrees to get to a full circle. See, we're short 30 degrees. So 180 minus 30 is theta is 150 degrees. The second one, how do we get there? That's past 180, right? This is 180. So we're past it by 30 degrees, 210, because it's 180 plus 30. Okay, I'm gonna double check. If I write cosine of 150, would that give me square root of 3 over 2 negative? Well, let's try it. 150 cosine, is negative 0.86, which is our decimal version of square root of 3 over 2. That was right. How about at 210? Let's try it. 210. 210 cosine. Bam! Negative 0.86, which is square root of 3 over 2. Okay. We're going to go over one last set. If I give you cosine of 0, okay, we know that angle would be over here. That's 0. Now, I gave you the angle, you tell me the sides. To find the sides, we draw the triangle with 0, 1, 1. Cosine would be adjacent over hypotenuse. That would be 1. Now, what if I had to go backwards? What if I had to go backwards? What if I gave you cosine of theta is equal to 1? What angle would give me this possibility? Draw the cross like you normally would. Ask yourself, is cosine positive or negative here? Cosine is positive. All students take calculus. So where would cosine be positive? Cosine would be positive in quadrants 1 and 4. So we draw a triangle in quadrants 1 and 4. 1 and 4, just like what we did before. Mr. Cosine is adjacent over hypotenuse, but I only see a 1. What's the fraction? It's an invisible 1. Adjacent and hypotenuse are both 1. So adjacent is 1, and hypotenuse is 1. Whoops. Adjacent is 1, and hypotenuse is 1. Okay, remember this is the 1 on top and the 1 on bottom, okay? Have we seen this 1, 1 triangle? That means the third side is 0. So my point here is to now have you guys realize this is a mouse trap. You guys ever see a mouse trap? It snaps closed, right? The spring causes it to snap close, and that's what's going to happen here. Is there really a height here? No, if it's 0, shouldn't it just snap close? Shouldn't the snap close? Turns out, what is this angle? angle is 0. So like what we said before. There is no height. That should have snap close. Now, 90-degree angles are something you can draw triangles for. And I teach it this way, so you can always make sure you have the right angle, that it would be in a 90-degree. If you guys find doing triangles too difficult when it comes to 90-degree angles, you could also straight memorize it. As we mentioned before, this is 0, 1, negative 1, 0, 0, negative 1, because we went down. This is 1, 0, because we went to the right. Okay? These are my 4 90-degree possibilities. You could just memorize it. Cosine and sine, cosine and sine, cosine and sine, cosine and sine. Now, here is a fast trick for you. Ready for a fast trick? Sine is x or y. Sine is sine and cosine, okay? Sine is your y value, cosine is your x value. When, okay, so when your arm is straight up in the air, is that y is 1 or x is 1? Up in the air, 90 degrees, that's y is 1, right?
Yeah.
That means your sine is 1 at 90 degrees. But your cosine is 0 because you didn't go anywhere. At 180 degrees, hey, aren't you sitting on the floor? Aren't you flat on the floor? Well, if you're flat on the floor, that means your y value is 0. Your y value is 0, and your x value, because you went to the left, is negative 1. Going straight down to hell, 90 degrees, negative 90 degrees, or 270 degrees, going straight down to hell. If I start digging a hole straight down, my y value is going to be negative 1, but since I didn't go left or right, that's going to be 0. So cosine of 270 would be 0, but sine of 270, because that's your y value, is going to negative 1. And the same thing as 0 degrees. If I go to 0 degrees to the right, the x is positive 1, because I went to the right one, but the y value is going to be 0, because I'm lying on the floor. So your sine is 0. That's one way. If you can memorize this, that's also a fast way of doing it.
So then does that mean essentially the hypotenuse will never be 0?
Yes, correct. The hypotenuse is never 0 for us. It's always going to be a 0, 1, 1.